Previously, we were multiplying polynomials by a monomial. So we're going to take that one step further, and we're going to start multiplying binomials times another binomial. And we can actually set this up and solve it very similar to what you were doing with the monomials and the polynomials, and that is using the distributive property. Now I'm going to put this entire problem up here, but I just want you to look, and they've color-coded it here, so that's nice. Basically what you're going to do, and this question here is really good to look at, how can you use the distributive property with two binomials? Well, you're going to think of the second binomial as if it were a single variable. So you think of this entire parenthesis maybe as if it were just 1x, okay? And you're going to distribute to each one of the terms in the first binomial, okay? So this is actually kind of what they have here. 2x gets distributed to this entire thing. So the 2x gets distributed to this entire parenthesis, 3x minus 7. And then the 4 also gets distributed to this entire parenthesis. So basically you break that first binomial apart and place it in front of that second parenthesis. So you distribute each of those terms to this whole parenthesis. And then it's basically just the distributive property again. It says distribute 2x. Distribute 2x to 3x and distribute 2x to negative 7. So that's where this comes from when you distribute those. Then they just rewrote this problem again. And then you distribute the 4. So you distribute 4 to 3x and you distribute 4 to negative 7. So what you wind up with is a large a polynomial here, but it does actually have two terms that are like. So we can combine like terms. 6x squared minus 2x minus 28 will be your final answer after combining like terms. So just using the distributive property is all we are doing. And then you distribute each one of those terms inside the second parenthesis. So basically you're distributing 3 times. All right, we're going to look at another method. Actually, let's try one of these first before we move on to that method. I want you to try one. Use the distributive property on this problem, and I'm going to give you some answer choices here. Distribute the x to this entire parenthesis, then distribute the negative 6 to this entire parenthesis, and then simplify. All right, your correct answer is B. And just to give you an idea of how you would solve that, you distribute the x and the negative 6, then you distribute each of those into the parenthesis, and then simplify. All right, now we're going to look at a different method, which is the method that many of you will probably prefer when multiplying two binomials.
In this problem, you will multiply binomials using the FOIL method. What is the simplified form of the binomial 5 times x minus 3 times the binomial 2 times x plus 1? How can a diagram help you multiply two binomials? Draw arrows from each term of the first binomial to each term of the second binomial. This will help you organize the products of the terms. FOIL stands for first, outer, inner, last. Look at the binomials being multiplied. 5 times x minus 3 and 2 times x plus 1. The first terms of these binomials are 5 times x and 2 times x. The outer terms are 5 times x and 1. The inner terms are negative 3 and 2 times x. and the last terms are negative 3 and 1. Now simplify this expression. So the product is 10 times x squared plus 5 times x minus 6 times x minus 3. The product in simplified form is 10 times x squared minus x minus 3.
Now basically if you just notice they're just distributing. You multiply 5x times 2x, those are your first terms. And then you multiply 5x times 1, which are your outer terms. So basically you're distributing 5x throughout that parenthesis. And then you do the same thing with negative 3 times 2x, those are the inner terms, and then negative 3 times 1, which those are your last terms. So you're just distributing and then completing your multiplication to simplify each one of those, and then obviously collect your like terms.
Now it's your turn.
All right, simplify this using the FOIL method. Pause the video. Here's your answer choices. Pause the video and give yourself a minute just to multiply that through. Your correct answer is A. And here is the solution to that. Here's your answer A here. These are the first terms, your outer terms, your inner terms, and your last terms. They set this up vertically instead of horizontally like the last example. But then you just simplify your polynomial by collecting your like terms. And if you follow the FOIL method correctly, your outer and inner terms will always be the two that you can simplify if possible. So always pay attention. And this is most of the time. Sometimes the binomials can be rearranged, and so it may not necessarily always be outer and inner. I probably should clarify. But if your binomials are in standard form, then with outer and inner, those are typically the ones that you can simplify because they're like terms.
In this problem, you will apply the multiplication of binomials. A cylinder has the dimensions shown in the diagram. Which polynomial in standard form best describes the total surface area of the cylinder? Your choices are 4 trinomials. The total surface area of a cylinder is given by the formula SA equals 2 times pi times r squared plus 2 times pi times r times h, where r is the radius of the cylinder and h is the height.
Okay, so this is quite a lengthy formula, but this is the surface area of a cylinder. And the r's are going to be the same values. You just use them in two different places. Pi, you all know what pi stands for. And then, of course, your height is the height of the cylinder itself.
Use the formula for the surface area of a cylinder. Substitute x plus 1 for r and substitute x plus 4 for h.
Okay, so notice that the radius was x plus 1, so they just put that in place of r. And x plus 4 was the height, so they just put that in for the height, for the h.
How can you simplify the quantity x plus 1 squared? Write it as the quantity x plus 1 times the quantity x plus 1 and multiply the binomials. You do not distribute the exponent to each term. In other words, the quantity x plus 1 squared does not equal x squared plus 1 squared. Write the quantity x plus 1 squared as the quantity x plus 1 times the quantity x plus 1.
When we had our exponent rules, we did not deal with any addition problems. We had things like 4x or 3x, which was a product raised to a power, and that's when we could actually distribute. We no longer have those types of exponent rules with these binomials because we're dealing with addition and subtraction. So you cannot just distribute this exponent in like we were. You can only do that when you have a product or a quotient, and that's not what we have here. We have a sum, we have an addition problem. So you cannot distribute, you just have to write it out. There are two of them. There are two x plus 1s, so you write both of them out so that you can use the FOIL method to simplify.
Now multiply the binomials. Combine like terms in each product. Now factor out 2 times pi. Again, combine like terms. Finally, distribute 2 times pi in order to write the polynomial in standard form.
So basically what we've done, they're finishing this out, but the reason they took 2 pi away is because it's like the factoring we were doing in the last unit where you take out that common term.
The correct answer is C.
And then they simplified. So this just gives you a good view of using this in other terms other than just multiplying binomials, but how you can apply it to geometry type situations.
In this problem, you will multiply a trinomial and a binomial. What is a simpler form of the trinomial 3 times x squared plus x minus 5 times the binomial 2 times x minus 7? Multiply by arranging the polynomials vertically. How should you align the polynomials? Write the polynomials so that the like terms are vertically aligned. Multiply the trinomial by negative 7.
This just gives you a different viewpoint of how to multiply. And in this case, something that's a trinomial times a binomial rather than the binomial times a binomial.
This product is negative 21 times x squared minus 7 times x plus 35.
So it's kind of like multiplication, old school really, where you're multiplying vertically.
Now multiply the trinomial by 2 times x.
And they're aligning the like terms here so that they can go ahead and add those when that time comes.
This product is 6 times x cubed plus 2 times x squared minus 10 times x. Finally, add like terms. So the product in simplified form is 6 times x cubed minus 19 times x squared minus 17 times x plus 35.
Now another way you could do this is just distribute 2x to each one of these and distribute negative 7 to each one of these terms and then simplify, which is the exact same thing they did here. They just aligned it vertically to distribute each one of those before multiplying or before adding. So now I want you to try one. So
now it's your turn.
Pause the video and try this problem. Here are your correct answers, or here are your answer choices. Pause the video and try this problem. Your correct answer is, make sure you distribute this or line it vertically, that's fine, but your correct answer is D.